Assalamualaikum and hi guys. Today my team and I gonna make an experiment to prove Bernoulli equation. But first, let me introduce my team. This one is Muzammil, Amir, Izzadin, Luqman, and me, Amalina. Did you know what is actually Bernoulli's principle? Now, let's get started with introduction to Bernoulli's principle. Bernoulli's principle can be proved by Bernoulli's equation. Bernoulli equation describes the relationship between pressure, velocity, and elevation. Let's take a look at the condition to apply Bernoulli equation. The fluid must have constant density, incompressible fluid, steady flow, and no losses from fluid friction. Furthermore, let's discuss about the energy conservation law. Energy conservation law states that if fluid travel from broader to smaller pipe, it will travel with greater distance with greater velocity. Work done performed would be represented by the product of pressure and volume. Speed in narrow pipe is greater, thus kinetic energy would be greater too. What is actually the objective of this experiment? The experiment is carried out to investigate the validity of Bernoulli principle when it is applied to steady flow. Now, it's time to make our experiment.
Okay, Assalamualaikum warahmatullahi wabarakatuh. So my name is Muhammad Izzuddin bin Rusli. I'm from EC220 3B3. So today I would like to talk about my task, which is theoretical background for topic Bernoulli theorem experiment. So energy present in a form of pressure, velocity and elevation in fluid with no energy exchange due to viscous dissipation, heat transfer and also a shaft work. So the relationship among these three forms of energy was first stated by Daniel Bernoulli based upon the conservation of energy principle. So Bernoulli theorem pertaining to a flow streamline is based on three assumptions, which is number one is a steady flow, number two is incompressibility fluid, and also last is no losses from fluid friction. So this validity of Bernoulli equation will be examined in this experiment. So next is like I told before, Bernoulli theorem assume that the flow is frictionless, steady and incompressible. So these assumptions are also based on the law of conservation of mass and energy. So example like Q in equals to Q out, and also E in equals to E out, same like Q1 over equals to Q2. So like we see in this equation, P1 plus 1 over 2 rho V1 squared plus rho GH1 equals to P2 plus 1 over 2 rho V2 squared plus rho GH2. So like you can see, the right hand side and the left hand side is the same. So according to this principle, the total heat is a constant as shown in this equation. So when is in SI unit, so P is a fluid static pressure at the cross section in Newton per meter squared. The unit is Newton per meter squared. So rho is the density of the following fluid in kg per meter cube. So G is a gravity in meter per second squared. Value of G normally is 9.81 meter per second squared. V is the mean velocity of the fluid flow at the cross section in meter per second, and Z is the elevation height of the center of the cross section with respect to a datum Z equals to 0 normally. So H is a total stagnation head in meter. So next is lastly, we can find the flow rate using this formula, which is Q equals to V over T. So Q is a flow rate equals to V. V is a velocity over T. T is a time. So that's all from me. Thank you very much.
Assalamualaikum and hi. This is our prototype. Okay, for the experiment we are using water container, stopcock, and 15 millimeter for the meter of pipe and bucket.
From this experiment, we're using two different opening bars. First, 45 degrees and second, 90 degrees. We're using three different of water level. First, 2 liter, 2, 3 liter, 3, 4 liter. That's it.
Result and calculation for Bernoulli experiment. We start the experiment with opening valve at 45 degrees and we're using formula to find area with we're using formula pi r square divided by 2 and we get 8.835 times 10 power of negative 5. And for velocity, we're using Bernoulli equation and we simplify it to velocity equal square root 2gh. So h we get from 2 liter and we measure it and we get 0.041 and we calculate and we get 0.897 meter per square for velocity. And for flow rate, we're using formula Q equal area times velocity. And we're using the velocity that we get. And for the calculation, we get 7.925 times 10 power of negative 5 meter cube per second. So we continue with 3 liter with using also the same equation
And we get velocity
and we get velocity 1.295 meter per second. And for the flow rates, we get 1.144 times 10 power of negative 4 meter cube per second.
for 4 liters.
And we continue with 4 liters. And also the same equation for velocity using Bernoulli equation and we get 1.785 meter per second. And flow rate also the same equation, we get 1.577 times 10 power of 4 power of negative 4 meter cube per second.
So let's continue for
And
opening valve.
let's continue for the second experiment with opening valve at 90 degree. And for the experiment number 1, with area, the formula is pi r square. And we get 1.767 times 10 power of negative 4.
So for this calculation, 2
For
liters.
this calculation, with 2 liter, we guess velocity with using Bernoulli equation and we simplify it to velocity equal square root 2gh and we get 0.897 meter per second
Same with 45 degree opening valve.
with same
With 45 degree.
formula with 45 degree.
So, but flow rates,
For the flow rates, we use also the same equation
but area
like 45 degree. We're using Q equal area times velocity and we get 1.585 times 10 power of negative 4 meter cube per second. Also the same step with 2 liter, we continue with 3 liter. For velocity, we get 1.295 meter per second. And flow rate, we get 2.289 times 10 power of negative 4 meter cube per second. And for the 4 liters, also the same step. We're using Bernoulli equation and we simplify it and we get 1.785 meter per second. And the flow rate we get 3.154 times 10 power of negative 4 meter cube per second.
That's all.
That's all.
The aim of this experiment is to find out the validity of the Bernoulli theorem when it is connected to the steady flow of water. Since the volume of water that passing through the pipe is different, the time taken will be also different. From the Bernoulli principle, it is stated that the higher the flow rate, the lower the pressure. So, the higher volume of water that passing through the pipe, the lower the flow rate that will be produced and the higher pressure will be produced. In this experiment, there are several errors that we should be considered. The first error is parallel error. Parallel error may be happen during the observer taking the data from the ruler. For prevention, the eyes of the observer should be parallel to the ruler. The next error is the data taken too early. The data should be taken on time. So, for prevention, the observer should know the progress of the experiment, so the data will be taken on time.
It's time to wrap this up. From the experiment, it is concluded that the velocity of liquid increases as the volume of liquid increases. The higher the volume of water, the slower the flow rate. Then, the pressure of water will be higher. Thus, Bernoulli theorem is valid. That's all from us. Thank you.